So we are going to calculate the volume that is bounded by the graphs of these four equations. These two are vertical parabolic cylinders, and these are the planes. So first let's look at a graph generated by MATLAB. So here is a graph, and you can see one of the planes forms the floor, and here is a ceiling, and the two cylinders, they are forming the wall, or walls. So just to repeat, what we got is we have to compute the volume bounded by these two vertical parabolic cylinders and these two planes. The top one being 2x plus 2y minus z plus 18 equals 0, and the bottom one is x plus y plus z equals 2. Now both these planes, in the region that they are intersecting with the parabolic cylinders, they are above the xy plane for that portion. All right. So in order to calculate the volume, one strategy is just compute the volume under the graph of this plane and over the xy plane that is bounded by the intersection of these two surfaces, and then compute the volume under this and over the xy plane and take the difference. So let's see what we are going to integrate over. So we are going to take a double integral over this region in the xy plane that is bounded by the graphs of those two parabolae, that is y equals 1 minus x squared and y equals x squared minus 1. So our region of integration. Now one way that we can integrate over this region is that let x vary from -1 to +1, and then y will just take values from where to where, x squared minus 1 to 1 minus x squared. So let's just go ahead and set up our integral. So our integral will be set up as, we have x ranging from -1 to 1 in the xy plane, and y ranging from x squared excuse me, -1 to 1 minus x squared. All right, and then what we will do is that we will take the difference of the two integrals. So who was the upper plane? The upper plane was, if you remember, let me type the equation again here. So the top plane is 2x, z equals 2x plus 2y plus 18, and the lower plane is what? The lower plane is 2 z equals 2 minus x minus y, and we are going to integrate with respect to y first. This is what our order of integration is, and then with respect to x next. So what we get when we proceed in this manner, we simply have so let me remove this here. So we will have what? We got 2xy, right? And here 2y, when integrated, becomes y squared over 2. So the 2 will cancel. Then I got an 18y. Then here I'll get a 2y, then xy, and then here I am going to get, what will I get? I'll get y squared over 2, right? And let's just remove this dy here, and our upper limit is what? 1 minus x squared, and the lower limit is x squared minus 1, right? Okay, so we can do it like this. If we want, we can go ahead, and actually let us go ahead and do that anyways. We can combine the like powers. So what will happen is y square, and then negative negative is positive. So y square and y square over 2, when they are added, what they will become is 3y square over 2. All right, I'll erase this first. Let me just calculate these all. Then we got 2xy, then negative negative xy. So what that gives us is 3xy. Okay, and then at the end we got 18y, and then minus this 2y, which will give us how many? 16y's, right? So we get plus how much? 16y between those values. And now we can just go ahead and write the limits down. So what we shall have here is that this will be, when we apply the upper limit, 1 minus x square quantity squared again, because that's y square, right? And then we will have minus x square minus 1 square. And I confess that I'm probably typing it a little too fast, because doing some calculations in my head, for which I may make mistakes. So we'll see. All right, and then here what happens? We'll get 3x times how much? This upper limit, right? And then minus 3x times the lower limit, right? Okay, and then let me just go ahead and reduce the font size, because I hope you can still read it. Hopefully you will. Okay, and then we have 16y simply, so that will follow the same pattern. All right, and all I'm doing is just simply doing algebra. Okay, and then we got 16 times, and here what we have is these will switch. Okay, and okay, we can keep that in the same line. I hope you all can still see it. Okay, so when we simplify this, what we get is, let me just do the algebra and bring it back to you. So what we got is, first of all, let's remove these. Okay, so we have what do we have is that you can see these are squares of the same quantity with different signs, so they will go away. All right, so that is out, and I can increase the font size again. And then you have 3x, then plus 3x here, so that becomes how much? 6x, and then you got negative 3x is x cube, then negative 3x cube again, so that gives us negative 6, and then what? Negative 6x cubed. All right, then 16, then plus 16 here will give us a 32, and then negative 32, oops, sorry about that, minus negative 32 x square. Erase all this mess here. Okay, so what we got here is we got this polynomial of degree 3, and this will just be say a routine definite integral of one variable. So let's just let the computer do it for us. Okay, all right, so I'm just going to let the computer compute it. So the answer is 128/3 for the volume.